Good afternoon, everyone. Thank you for still being here. So before I start my presentation, I'd like to acknowledge my co-authors, who actually happen to be my grad students back at NC State. And also very much appreciate the extensive funding by the National Science Foundation, and also in part some of this work is funded by SSHRC and through the LEADS project, which we have some members here, Eunice Jang and some of my collaborators, Inga, Molinar, and Maria Bannert, and several others. And that project is led by Sue Lajoie at McGill University. And so today, there's a lot of firsts this week. It's my first time at LAK, so it's the first time also presenting this conceptual framework, so take it easy on me. I'm not going to be able to present everything and all the assumptions. Just going to give you a snapshot. If you want more information, we can talk about that later. We also have a chapter coming out that's the extensive version of the 5-page paper. And really what we've been doing for the last 18 years is really focusing on self-regulation and advanced learning technologies, focusing mostly on cognitive and metacognitive processes. However, in the last 6 years, we've focused on emotions because we've been ignoring emotions. So we collect a lot of multimodal, multi-channel data, as the two other presenters have shown you today. And then this morning also with Sydney's keynote and several other keynotes also like Sana on a couple of days ago. So we collect a lot of these data. We started thinking, you know, we're hogging up this data as researchers so that we can make inferences about students' ability to monitor and regulate their cognitive, affective, metacognitive, motivational processes. But the question is, can we take these same multimodal, multi-channel data that we use as scientists and repurpose or reformat these data, okay, and give that back and feed those back to the learners so that they can actually engage in emotion regulation. Okay, so we see a lot of work in emotion. There's obviously affective computing. We got some experts here at this conference. But the question is, how can we help students regulate their emotions? Okay, and is one way of doing that by re-representing some of this multimodal, multi-channel data and feeding it back to them. And also, when I talk about advanced learning technologies, I am talking about a whole class of technologies. So intelligent tutoring systems, multimedia, hypermedia simulations, augmented reality, etc. This is going to be a term that we use in the literature as a catch-all phrase. And as I mentioned, this is the initial step in terms of the conceptual framework. So just an overview so we all have the same grounding. Emotions, obviously, as we know, play a critical role in SRL with advanced learning technologies. And what we want to do as we think about how do we re-represent this multimodal, multi-channel data and feed that back to students to help them monitor and regulate their emotions is that we really want to pinpoint, because we're using multimodal, multi-channel data, is really make the link explicit for the students as we represent this information and feed it back to them is that there are cognitive, there are metacognitive, and there are motivational bases for the emotions that they are experiencing. So for example, when a student is using MetaTutor, top left, okay, and we notice all of a sudden, because we are collecting facial expression data, that they're transitioning from neutral, let's say, to confusion, okay? And the question is, why is that, okay? Is it a skill issue? Is it a knowledge issue? Is it because the agent just told you to summarize because he has been monitoring the fact that you've been spending a lot of time on this particular topic, and now it is time to summarize. But now I'm showing, for example, a particular negative affective state, and the fact is, it's because I don't know how to use that strategy. I may not even have the declarative knowledge. What is that strategy, let alone how to use it? So we want to basically pinpoint a lot of this work. If we look at Crystal Island, just like Zenu just presented, okay? So when a student, for example, is showing confusion, and that's because they're interacting with Kim. Kim is the camp nurse, okay? She's giving the symptoms of the patients that you see there, okay? So they may have diarrhea, they may have this, we're not gonna get into this, I know it's past lunch, but multiple symptoms, and the question is, I don't know how to put all these symptoms together because I'm supposed to engage in scientific reasoning. So we need to understand the basis of these affective processes. Again, multimodal, multi-channel data, captured with learning, okay? And can we feed these back to the learners? And so we raise questions of which representations, how do we represent it, when do we feed it back to you? This is, of course, all assuming that students engage in the appraisal process, okay, in terms of actually monitoring and regulating their emotions. So there are a lot of assumptions here that I'm making it implicit, okay? I'm not making them explicit because of the time. I'll share some of the core assumptions of the framework and give you some examples of static and dynamic data representations that we want to consider feeding back to the learners to facilitate that monitoring and regulation of their emotions. And if we have time, we'll talk about future directions and implications. So I've already talked about MetaTutor and Crystal Island. Now, some of that work with the geospatial scientists at NC State, okay, on the bottom left. So here now, we're no longer talking about students learning about science or using a serious game to look at scientific reasoning. Here, our students, they're they're using tangible computing. This is kinetic sand. It's collaborative problem solving. One of them using is a portable eye tracker. The other one using the Be Alert EEG. They're both wearing the Empatic E4, and they are solving real-world problems. They're solving a problem of coastal inundation from North Carolina. They have to coordinate. So, for example, if the student on the right-hand side shows anger, okay, which we tend not to consider because that is a basic emotion, but sometimes they do show anger along with things like confusion, okay? And so the question is, we need to understand the context, as mentioned before, and several times throughout this conference, in order to be able to, can we select the right multimodal, multi-channel data to feed back to the students so that at that point in time, that is the right representation to facilitate the monitoring and regulation of their emotions, okay? And so there's several examples. How do we collect this data? You know, we collect it in the lab. Well, the student is instrumented, up the wazoo, as we like to call it, okay, without electrocuting them. But also in real-world context. So we do a lot of work in simulations where it's team performance. And for example, there you see a high-fidelity mannequin, okay, on the bottom right. And where you have is looking at team performance, where you have an expert and several residents. And the goal is that you have 10 minutes to solve this critical care patient without killing the mannequin, okay? And the mannequin does emote, the mannequin does talk back to you, etc. So in this case, it's a combination of learner-centered emotions and basic emotions because somebody's life is on the line, okay? So a lot of context, different kind of context. These are some of the emotions that we see, at least with MetaTutor. So you have confusion, frustration, surprise, neutral. This is just a subset. And really the question is, when does this happen? For how long does it happen? It happens in a particular sequence, okay? And the question is, what is the root basis for expressing confusion? Is it cognitive? Is it metacognitive? Is it motivational? And in some cases, basically it's a vicious cycle of an inability to regulate one's emotions, all right? So, well, as psychologists, we love theories and models and frameworks, so we got to go into the literature, right? If we're going to provide a conceptual framework of emotional regulation, what do we have, right? Yes, we have cognition, metacognition, motivation, but if we look at affective computing and we look at engineering, computer science, psychology and education, we obviously borrow from Sidney and Art's model, right? Affect dynamics model is extremely important. We've also tried to merge that model with Klaus Scher's model because that Klaus Scher's model, okay, is also an information processing model, if you will, to a certain extent, and really focusing on different appraisal mechanisms because we're treating emotions as a multi-componential system, okay? And I'm not going to get into that because it takes at least 5 hours just to unpack Scher's model, okay? But there's a synthesis, and because we're focused on emotional regulation, well, we don't have to come up with a new model. Can we not use James Gross's model of emotional regulation, even though that comes from social psychology, neuropsychology, and clinical psychology? And he's got 5 very specific emotional regulation strategies, starting with situation selection, situation modification, deployment, cognitive change, and response modulation. And what I want to show next is we're not going to focus on the first one because this is not a clinical situation. When we have a student in a classroom, laboratory, or some real-world context using an advanced learning technology, we already assume that situation selection is unachievable in terms of an emotion regulation strategy. So we focus on the other 4. And the question is, can we map these onto some generic, okay, scaffolding approaches, which have their own multimodal representations, and some that are more dynamic. So, not to bombard you with more, if we look at the literature, okay, these are some of the key issues, okay, interdisciplinary issues that have been raised in the literature, in the various literatures, okay, that are extremely important. And again, I don't have time to go into this, okay, but affective episodes, appraisal mechanisms are at the core of emotional regulation. So we need to understand what that appraisal mechanism is if we are going to be presenting multimodal, multi-channel data to the students and assume that they can monitor accurately and they can regulate accurately so they can perform well, or learn, or reason, etc. So, again, proposed conceptual framework, here are some core assumptions. Again, this is not a complete list. We assume that students can, monitor and regulate their CAM processes. That we make the assumption also, and this is debatable, that multimodal, multi-channel CAM SRL data are relevant and can potentially be used by learners to monitor. The other issue is a re-representation issue. So, for example, are we going to take, the screen recording that we have from Facet when we use iEmotions? Is that the kind of representation that we would feed back to a student, either on a dashboard or an open learner model or some kind of interface element? Probably not, okay? So we have the worry about the re-representation, and in some cases, we may require multiple representations to facilitate motor regulation. Some of the key issues are number of representations, the type of representation, representation? Do we show static representations? And I'm going to show you that next. Or should it be dynamic? Okay? And when? Ease of understanding, configuration of the representations, and of course, this does not need to become a dual task. If we're going to show you representations to facilitate your monitoring and regulation of your emotions, they have to be actionable. Okay, so I got to be doing the less amount or least amount of interpretation of what you're trying to convey to me through my representations of my affect data. We also worry about coordination. Here's the temporal issue and synchronization of these visualizations, okay? And also the presentation, right? Where, you know, at the end of the day, I'm a cognitive psychologist. I got to worry that, yes, we have working memory capacity issues, we have attentional issues, and there are also individual differences that we need to take in consideration when we consider what type of representations should be fed back to each individual learner without, of course, exceeding these. And also the timely presentation. Should we just show you multimodal representation at that point in time, okay? Or do we need to take the history of the fact that you have already had 15 episodes of confusion, okay, during your 3-hour interaction with this particular ALT? And if that is so, is that representation after the 15th time, should that be the same as the first one that I showed you, or the second or third? Okay, so it involves re-representation. 5 minutes, okay, good. All right, some more coffee. So here's some sample data. So this is basically to say that given your different multimodal, multi-channel data, we get different types of indicators, okay? And one, of course, I highlighted some of the ones in red, which are important. So what this multimodal channel data will give us is the emotion eliciting event. So, for example, it could be the intervention by a pedagogical agent or an intelligent virtual human that just asks you to do something, or it can be based on the representations that are involved. If it's eye tracking, should we show the student the overall gaze behavior? Does that help understand as to why you didn't do well on that next quiz? Well, it's because you didn't actually pay attention to the right content, and I'm going to show you that in a second. Log files, etc. Here is a sequence, right? So yes, you asked me to plan, I planned. I set some goals, I read some material, and then I used some strategies. But then when I took the quiz, I got my feedback, in fact, that I got 33%, and all of a sudden, I'm getting frustrated. Okay, so what do we do for you right there before you continue on with your instructional path? So this is basically some affective indicators based on the multimodal, multi-channel data. What I want to show you some examples, and I'm running out of time. So if we're going to think about static multimodal data visualizations, okay? So in this case, imagine being able to show the heat map, right? For collecting eye tracking data, at what point would a static diagram of a heat map of your behavior, because you're trying to answer a science question, okay, which is presented here, okay, and we show you that, okay, well, you paid a lot of attention to this third paragraph, but guess what? You didn't do really well because we know, all right, and you're getting frustrated because you didn't pay enough attention to the human agent, okay, who was trying to provide you with some scaffolding, right? So does that mean this is the right representation at that point in time? And if we were to present this data to you, how would you change your behavior, okay, and would that impact your performance, all right? Or is that too subtle? Okay, in some cases, you know, because we work also in Crystal Island, we have a couple of grants. So you're reading about viruses and bacteria. At some point, you have to tell us the differences between these two, right? Well, you know what? We've actually instrumented the eye tracker, okay? Well, what about if we show you your gaze behavior, right? The reason why you still don't understand the difference between viruses and bacteria is because I'm showing your gaze behavior is that you actually did not fixate, you did not read that particular area of this book, okay, that was relevant. So that's a pretty simple fix that could be done. The issue is, does the student internalize this? Does the student then change their behavior? And is this the right representation to engage in the accurate monitoring and regulation of one's emotions? Okay. In some cases, right, we talk about, well, this is actually a screenshot of some of the software that we use for my emotions. All right. In this case, should we present, again, this is open-ended, should we present the student, here you're seeing your gaze behavior in real time. So we may have to slow it down. But, you know, in this case, it's probably better for the student to understand why they didn't get it wrong and why they are confused about this particular question, okay, because we can see, all right, their gaze behavior. And in fact, at the bottom, which is the facet data, the emotions in terms of evidence score, there's nothing really exciting happening until they get right there. If you look at his face right now, okay, there's surprise. Okay, and so the question also becomes, is surprise at that moment in time important in terms of anchoring students' engagement with the content? Okay. Other cases, this is a little more complicated. So now let's say we have a student who continues to fail to monitor and regulate their emotions and still doesn't have the skills and the knowledge and can't self-regulate. Well, in this case, we may need a case where here you have the student on the bottom, so I can see what I did when I interacted with a MetaTutor agent, okay? And you can actually see, so imagine I'm the student, and I can see my gaze behavior. So right now I'm fixating on that box because I'm actually setting a sub-goal to learn about the circulatory system. And I can see the feedback. So I can reflect on the feedback that she gave me. So is my misunderstanding, my confusion based on the fact that I didn't understand the feedback she gave me? Okay? So I'm going to turn this volume off here, and we're going to just one more slide if that's okay. So as you can tell, this gets a little more complicated. Okay, the question then becomes a computational issue, right? If we're going to present in terms of the timing, when do we present this kind of more sophisticated, multimodal, multi-representational data back to the learner, okay, to address the issue, okay, regarding their emotions, all right? And this can go on, and so open question. Right? So these are just suggestions, okay, since we do have this rich database and so many of us in this community. So the first thing we need to do is obviously continue articulating the assumptions, okay, and we obviously need to empirically test these proposed core assumptions, core context, advanced learning technologies and tasks and learners, and really focus, I think, on the cognitive, metacognitive, and motivational basis of emotion regulation. And these are some of the key issues, however presented, whether it's an open learner model again, or a dashboard, or some other interface element, is really trying to determine the optimal representation, the selection, the timing, the sequence associated with presenting these representations to foster, hopefully, and scaffold emotion regulation across students. And are they effective, and how do we know that they're effective? We need empirical basis for these. And I think this, in terms of also our HCI colleagues, is that the designing intelligent interfaces to foster emotion regulation, whether it's gaze behavior, so we're doing some work with the geospatial analytics, where we're using gaze to actually look at geospatial analytics. So of course our military colleagues and NSA colleagues are very much interested in that. But also what about brain-computer interfaces, okay, and augmented reality. And of course, none of this work is possible without, as somebody mentioned this morning, I think it was Sydney, a village back home, and a village both nationally and internationally of wonderful colleagues and collaborators. Thank you.
Okay, sadly we have no more time. I think we have a coffee break. Feel free to corner Roger somewhere to ask your burning questions, please.
Okay.
Thank you.
Thank you.